Okay, let's jump into learning a little bit about atomic energy levels. First thing I want to point out, it's important that you're taking notes on these. The worksheets that I gave you in class is not your notes. Those are similar to the practice and the graded worksheet that you'd get if we had a lecture. So you still should be taking notes on this. Pause the video as you need and ask clarifying questions in class. Let's jump into things, atomic energy levels. Before we jump into the physics and the math behind it, let's go over a little bit of history. Oh. Okay, so J.J. Thomson was the first person to really dive in deep when it comes to the atom. He was looking at all the makeup of the atom, and he recognized that there's electrons, that they're relatively low mass, and he also knew that the atom was neutral. So he concluded that if there was electrons that were negative, there must be protons that are positive. Okay, well, how do they come into play? He concluded that it was a mixture, or a plum pudding, of protons, electrons, just all together to form an overall neutral object. Let's take it a step further. Rutherford, in 1909, conducted his gold foil experiment. Now, this you guys learned about earlier in the year, and the gold foil experiment, there you go. The gold foil experiment took alpha particles, shot them at some gold foil, and observed the results. And what Rutherford noticed was most of the alpha particles went straight through and were almost unaffected, but a small number of them bounced back. How could that be the case? So what he concluded, which was successful and true, was that the atom is made up of relatively nothing, relatively emptiness. But in the very, very center is a very, very dense nucleus. And that's why these would bounce back, because they'd hit the nucleus and come back. Think of a football field, and in the very center is a golf ball. Relatively, that's an atom. The golf ball represents the nucleus, and the entire football field represents the nothingness of the atom. Let's take it a step further with Niels Bohr. Niels Bohr noticed that electrons only travel in certain orbitals. They can't be anywhere over the span of that football field, over the span of that nothingness. They can only be specific, distinct orbitals. And it's important to note that each orbital represents a particular energy. Now, jump back to chemistry. We know that when electrons are moving through the atom and they're in a high energy orbital and they jump from a high energy to a low energy, it emits energy in the form of light. And when they're at a low energy level and we put energy into it, they're able to excite and go to a higher energy level. Okay, so we're going to look a little bit of this math and look at the relationship between all of these energies.